Welcome to solverfy.
So for part A, we want to find the maximum velocity. This will be equal to the angular velocity times the amplitude, and this would be equal to 2 pi times the frequency times the amplitude. Now we can solve. So this would be 2 pi times the frequency of 2.5 hertz, and then times the amplitude of 0.15 meters, and we find that the maximum velocity equals 2.356 meters per second. We can find the velocity at equilibrium to then be equal to plus or minus 2.356 meters per second. For part B, velocity, we're trying to find the velocity at a certain displacement. So we can say that the velocity is going to be equal to plus or minus the maximum velocity times the square root of 1 minus x squared over a squared, and this is equaling plus or minus 2.356 times the square root of 1 minus 0.10 divided by 0.15. This is squared, and we find that v is going to be equal to plus or minus 1.76 meters per second. So this would be the final answer for part B. My apologies. And then for part C, we want to find the total amount of energy. So this would be, the total amount of energy would be equal to 1/2 times the mass times the maximum velocity squared. And this is equaling 1/2 times the mass of 0.35 kilograms times the maximum velocity of 2.356 meters per second, quantity squared. And we find that the total amount of energy is going to be equal to 0.971 joules. For part D, we want to find the maximum displacement at t equals 0 seconds. We know that this, if the initial position is going to, if the initial position is at the maximum displacement, this means that the general equation will be a cosine graph. So this is a cosine function. And so x, the general formula, would be equal to the amplitude of 0.15 meters times cosine of 2 pi times the frequency of 2.5 hertz times t. And so this is equaling essentially 0.15 meters and then times cosine of 5 pi t. And so this would be our final answer. That is the end of the solution. Thank you for watching.